All right, so on this first example, this is a basic solve for x problem. What we want to do is get all the x's to one side, all the constants to the other side, isolate the x, and solve. So to do that, I have x's on both sides, so I'm going to add x to each side, and that's going to allow me to consolidate my x's. So plus x and plus x. X minus x is 0, so those go away. And over on the left side, I have 2x plus 5 equals 0. Now I'm going to subtract 5 from both sides. That's going to give me 2x equals negative 5. Now I have a 2 connected to the x through multiplication, and so I can divide both sides by 2 to cancel that. And I get x equals negative 5 halves. And that's it for this problem. What's up?
What about if you solve it like that?
If you didn't solve it exactly like this, but it was similar to this, if you used a different algebraic method, totally fine.
Like just subtracting the x minus x from both sides.
Yeah, that's totally fine too. Yeah, exactly. Yeah, that's the thing with these ones. Like, yeah, I just did it one way, but if you don't break rules, you can use the addition rule to, like, yeah, throw the x's to the other side or whatever you're comfortable with. Okay, go ahead and give yourself a score on that one. Like, you know, if it was no problem and you just did it with the answer, give yourself a 10. You know, if you got the wrong answer but you sort of knew the right method, give yourself a 5 or something. If you didn't even know the method, give yourself a big fat goose egg. Yeah, and this one, I mean, if you don't know this one, dude, you got to star this, because this is beginning stuff, right? You don't know how to solve like a basic x equals whatever equation, we definitely got to practice that. All right, so how about this one? This is one of the equations where we're solving for a variable. And so this one, I ask you to solve for y. Go ahead and I'll give you about, I don't know, 3 or 4 minutes. See if you can solve this guy. All right. So how we solve this guy, it's key to notice that we're solving for y, but y is contained in 2 different terms. And that's an indicator that we're going to need to collect those terms side by side and factor y out. So before I collect them side by side, I'm going to subtract the c over to the other side, and that's going to allow me to isolate those y's. So I'm going to subtract c from both sides. Okay, those c's are going to go away. And then I'm going to have x minus c on the left side equals ay plus by on the right side. So now all I need to do is reverse distribute these y's. Right? There's a y in each term, and so I can pull them both out. So I have x minus c times, or equals y times a plus b. Any questions on that step? Okay. All right, and so now we want to isolate the y. Y is attached to a plus b through multiplication, and so just like if a plus b were some constant term, we divide both sides to cancel it out. Sorry, we divide both sides by a plus b to cancel it out. So these two will cancel. I'm going to write it in reverse order here. Y is equal to x minus c over a plus b. Okay, so, you know, just a heads up, I mean, if I give you guys a problem like this on the test, it's going to be the kind that you're going to have to factor a number out, right? These are boring if it's just easy solve, right? It's more exciting if you got to factor something. Exciting for me, not for you guys. All right. Oh, sorry. Go back and score yourself, right? If you kind of knew the basic concept but weren't quite sure how to factor stuff out, like, you might give yourself a 4 or something like that. But yeah, if you weren't even sure, like if you didn't even make it to this step, you might want to give yourself below a 3. All right, next problem. So, oh, this one's kind of interesting. So this one says, during the 2016 longlining season, Lucy's vessel caught 25,000 pounds of fish. Roughly 70% of the total catch was halibut. Roughly 10% of the total catch was black cod. How many pounds of halibut and how many pounds of black cod did Lucy catch during this season? Okay, so this one, even though it's sort of set up and you might think, maybe that's a mixture problem or maybe that's a total value problem, this is a straight up calculating percentages problem. So the first question they ask is, how many pounds of halibut did Lucy catch? Well, it says up here that roughly 70% of the total catch was halibut. So 70% of 25,000 is what we want to calculate. So I say 0.7 times 25,000, and I get 17,500. So label that halibut. All right, part B, they want to know how many pounds of black cod did she catch? Well, that's still just a straight up percentage. It says 10% of the total catch was black cod, so we say 0.1 times 25,000, and we get 2,500. All right, so that's an example of a straightforward percentage problem. We'll do one close to the end here. There's a different kind of percentage problem that involves like finding out the original price based on a discount and all that. So go ahead and score yourself on that one. I think you're probably used to the system by now, right? Yeah, if you didn't even come close, make sure it's under 3. And really, this is a kind of a straightforward type of problem. And so, if you don't get this one, like, you really just got to study your percentages and stuff like that. All right, let's move on to problem 4. Problem 4 is just plotting points. This will definitely be on the final, right? Learn to plot your points because you get an automatic 10 points for this. It's easy as long as you know how to plot them. So the point 0, 4. That's 0 on the x-axis. This is x, this is y. So I go 0 on the x-axis and up 4 on the y-axis. The point 0, 4 is right there. The point 1, 1. I go over 1 on the x-axis because that's the first coordinate, and then up 1 on the y-axis. 1, 1. Sometimes it helps just so you keep these straight to just write XY right here, just so you remember that X is in the first position, not the second. For this next one, -1, -2, I go -1 on the x-axis, so that's 1 to the left, and then I go -2 on the y-axis. Oops, it's 1, 2. That is the point, -1, 2, -2. One last one, 5, -2. So we go 5 on the x-axis. That means 5 to the right because it's a positive, and then -2. 5, -2. All right. Typically, the only problem we have with this at this stage is just accidentally mixing up the x and y coordinates. That's a common mistake. Got to study these and got to make sure you write this x comma y to begin with, so you don't, so that you don't miss out on this problem. Because this is it's not really difficult as long as we have our coordinates straight. Go ahead and give yourself a score on that one. What's up?
Not giving us the time to do it.
Oh. I'm sorry. Don't give yourself a score on that one. Did I give you time to do the last one?
No.
I did not. Sorry, guys.
You were just on a roll.
I was.
We're just letting you go.
Whew, I was totally on a roll. Yeah, okay. So, all right. So don't give yourself a score on that one. Let's move on to the next one, I guess. Okay, writing an equation. Now I'll give you guys time to do this one. Thanks, Juan. So take about 3 or 4 minutes. All you got to do is write an equation describing a line containing these 2 points. All right. You should have an okay idea of how prepared you are for that problem. So remember, there are 2 equations that we want to know for a problem like this. Maybe 3 if they ask us to put it in a certain form, which this does not. The first equation is the slope equation. That is m equals y2 minus y1 over x2 minus x1. The other equation is the point slope equation, which is y minus y1 equals m times x minus x1. The only other equation that might be helpful with this problem is just the y equals mx plus b, and that's only if I ask you to put it in that form or to graph it afterwards, right? If it's just this problem, all you need is the top 2 equations. So first things first, we always want to find the slope, m, and then we just plug it in here along with one of the points. So first, let's find m. m is equal to y1 minus y2 minus y1 over x2 minus x1. So I'm going to call this x1, y1, x2, y2. All right, so I have a negative 2 minus y1, which is 3. And then I have my x2, which is 9, minus x1, which is 0. So I have negative 5/9 for my slope, m. So now that I have my slope, and I also have my y1 and x1 because I defined those, I'm just going to rewrite this equation down here with everything filled in, right? And so I'm going to say, okay, remember this, m equals negative 5/9, and x1, y1 is equal to 0, 3. Y minus y1 equals m times x minus x1. Now I just fill everything in, right? So the y stays the same. The y1 is equal to 3. M is equal to negative 5/9. The x just stays there because it's a variable. And then the x1 is just 0. So I can write minus 0, or I can just close it off. Right? You could write minus 0 over here, but why? It's just 0. So that's it for this line. Right? They don't ask you to graph it, so you don't have to.
They just want the equation.
Yeah, just the equation. This one will definitely be on the final. Oh, go ahead and grade yourself on that. And if you don't write these equations on your note card, you better memorize them because they're going to be there. All right, let's move on to problem number 6. So this one was a simplification problem where we basically just simplify the fractions until we get something. So I'm just going to kind of consider it separately, and so I'm going to do the constant terms first. 155 over 10. I think if I divide top and bottom by 5, I can simplify that. So 155 divided by 5, that is 31, and 10 divided by 5 is 2. So that's the first part of our fraction. All right, now let's take a look at the next thing in line here. So we have an a to the negative 13. There are no other, oh man, I didn't give you guys time to do this again. I got, all right. God, I suck at this. It has been a long day, but that's no excuse. My apologies, guys. Should we let you guys try it, or should I just keep going on this one?
Good.
Just keep going on this one, huh? Okay, sorry about that. All right, so I have a to the negative 13. There are no other a's on here, so there's nothing to simplify them by. All I have to do is get rid of that negative exponent, and I do that by, like Kevin likes to say, flipping it to the bottom.
Flip it.
A to the positive 13 now. Okay, so now I'm going to handle the b variables. So I have 2 negative numbers on my variables. So I'm just going to take the larger number and flip it to the top, right? And so I have b to the negative 73. I'm just going to keep b to the negative 1 up here for now, and I'm going to flip b to the negative 73 up to the top. So it now becomes b to the positive 73. Okay, now with our last variable, I just notice that k to the 0 equals 1. Anything to the 0th power equals 1. So that just goes away. Now all I got to do is simplify my b's, and then I'm good. So I still have 31 over 2. Oops. 31 over 2. Then I have a to the 13th on the bottom still. Now I have b to the negative 1 times b to the 73. Remember that we just add exponents. We're multiplying like bases, so this gives me b to the 72.
Why didn't we move these negative 1 down?
So we definitely could do that. It's just a different way of doing it. I left it up here so we could just multiply them and combine them. But we absolutely could have just flipped that b to the bottom and simplified that way. And so that would have looked like 31 over 2. B to the 73, a to the 13, and then just a single b to the 1 down here, and then we would cancel and say, oh yeah, we have a b down here, cancel 72. So it's the same, yeah, both are proper, both are right, I just prefer one over the other, it doesn't really matter. Good question. All right, now I'm going to give you guys time to solve these two.
Don't lie.
Don't lie. All right, so in the first one, we're just factoring completely, and in the second one, I actually want you to solve and tell me what x has to equal. If you're still working on part A, go ahead and move to part B and just see if you can solve that. See if you're going to remember the way to solve that guy. All right. So the first step whenever we factor is to see if there's a common term, or to see if there's a common factor contained in each and every term. For this particular polynomial, there's a factor of x in every term. So we're going to go ahead and factor that out first. So x goes on the outside, and in parentheses, we write what's left, which is x squared minus x minus 2. Now to factor fully, we just factor what's inside these parentheses. So I have x, it's going to split up into an x times an x. We're going to have a plus and a minus, because this last term is a negative, right? You can only make a negative by multiplying a positive and a negative. And we're looking for two factors, a negative 2 that add to a negative 1. Right? I mean, negative 2, clearly that equals negative 2 and positive 1. So we'll use that. So negative 2, positive 1, and there we are, fully factored. So now we use that factorization to help us with this solution here. So remember, when we solve for a polynomial like this, we throw everything over to one side, set it equal to 0, factor, solve each factor for 0. So I'm going to subtract 2x from both sides, and that's going to allow me to set everything equal to 0. So I'm going to have x cubed minus x squared minus 2x. I'm going to notice real quick, this is the exact same polynomial we just factored up here. That means we don't have a bunch of extra work to do down here. So I'm going to go ahead and write out the same factorization we just came up with, because we know that's what it equals. X times x plus 1, x minus 2, and that equals 0. So now I solve each one of these factors for 0, and each one of those x, for each x that makes one of these factors 0, you have a solution. So this first x, if this is equal to 0, the whole thing is equal to 0, and this would be a true equation. All right, for this one, x plus 1, how do we set that to 0? So if x were equal to negative 1, then x plus 1 would be equal to 0. And so what I want to do is say, okay, x plus 1 equals 0, and then solve for x. Minus, subtract 1 from both sides, I have x equals negative 1. So that's my solution from that particular factor. Now I'm going to solve this factor for 0. X minus 2 equals 0. If I add 2 to both sides, I get x equals a plus 2. Okay. So now I just write all my solutions in a row here. So I say x equals 0, x equals negative 1, x equals positive 2 are all solutions to this. We don't have any fractions involved in this, so there's no invalid solutions. Everything's valid. All right, go ahead and give yourselves a score on that guy. Alrighty. Okay, can you guys read those? Oh, you don't need to, they're on your paper. All right. All right, I'm gonna give you guys a couple of minutes to do these guys. All right. If you haven't taken a look at part B yet, take a look and see if you kind of know the general way to solve that. All right, so part A, there's actually two different ways to go about this one, which is not usually the case in these kind of problems, but for part A, this is the kind of division where you'll see the numerator, and it's definitely not really like factorable in the traditional sense, right? This one down here, we factor the numerator and try and cancel with the denominator, but this one here is a lot uglier. So kind of the more general way that'll work every single time is you split up these top two terms into two different fractions, right? So we write xy cubed over xy minus xy squared over xy. And that allows us to start canceling stuff, right? We couldn't cancel stuff before because that negative sign was holding us back. And so this is just the reversal of adding two fractions, right? So now we just pick out stuff to cancel. So we can see the x's both cancel on this left term, or on the first term. We cancel one of our y's, so that gives us y squared for this first term. For the second term, we have in parentheses xy squared. It's very important to keep those parentheses there, right? If we lose the parentheses, all of a sudden all we have is y squared, and it's a lot different. So we have xy quantity squared over xy. That means those cancel, and we have negative xy remaining. Okay, so if you can't really do a traditional factor on top, split up those fractions and cancel stuff separately. The alternate way to do this one would be to realize right off the bat that you have a factor of xy here, a factor of xy here, and also one at the bottom. So you could have pulled the xy's out right off the bat and canceled them. It doesn't usually work out that nice, but just to show you guys that there's a different solution. So you would say xy gets pulled out. What's remaining would be a y squared minus xy. And then on the bottom, we would have xy still. So those would cancel. And once again, we'd get y squared minus xy, which is the same as we got up there. Okay, so, but if you're going to study a method, this top method is the one to study, because this will work every time. This one down here only works if it's a nice problem. All right, so for part B, with these guys, we see kind of a traditional factor situation on top here. So we're just going to factor that guy out and see if it matches, if it has any factors of x plus 10 that we can cancel. So to factor out x squared plus 7 minus 30, we are looking for factors of negative 30 that differ by a plus 7. 5 and 6, nope, not even close. Those only differ by 1. 1 and 30, those differ by 29. 10 and 3, those differ by exactly 7, so that's what we want. Which one do we want to be negative? 3, right? Negative 3. And that's because 10 minus 3 is positive 7, and positive 7 is what our middle term was, right? If that were a negative 7, then we'd reverse those signs. All right, so we have x minus 3, x plus 10. And of course, a good indicator that it's going to be plus 10 is because I have x plus 10 on the bottom, and it's not going to be as nice without it. And I like nice things. Yeah, but as you guys know, sometimes I try and make them nice, and I screw it up. So. Oh, goodness. All right, so once we cancel the x plus 10s, we get just a plain old x plus, or x minus 3 there. Okay, number 9. I'm going to give you guys a few minutes to solve this guy. All right, should have the basic concept down right now. So this is a basic evaluation problem. All we need to do is enter in the right variable and calculate, and we're done. So it says P is the overall profit in thousands from producing and selling X boats. This is the key right here where it tells us what X means. The first problem says if we sell 4 boats, what is our profit? That means X equals 4 in this first problem. So I just calculate it. So P is equal to X cubed. Since X is equal to 4, I calculate 4 cubed. 0.02X, right? 0.02X. X is replaced by 4 minus 100. When you calculate all this stuff out, you end up with a, what is it, 64 minus 0.08 minus 100, which ends up being negative 36.8. So if this guy only builds and sells 4 boats, he actually loses $36,000, $36,800. How we do this part B, what if he only sells 1 boat? We do the same exact thing. We say P is equal to X cubed. 1 cubed is just 1. 0.02 times 1 is just 0.02. And then, of course, I still have the negative 100. That's going to equal negative 99.02. So this guy's going to lose almost all his money if he only sells 1 boat. It's crucial that he starts selling boats. Now, if this was a realistic polynomial, and this guy wanted to say, well, when do I get profitable? You have a question?
The first one shouldn't, I got negative 36.08.
0.08? That could be it. Oh, yeah, you're right, because this is 0.08 right here. That's exactly what it would have to be. Good catch. 0.08. Nice. Okay, so if we wanted to figure out when this guy became profitable, we would set this equal to 0 and solve for X. We're not going to do this, but if you wanted to, that's how you do it. And so just to sort of hash out this polynomial, why it sort of makes sense, I'm sure the real polynomial would be a bit complicated, but suppose this guy started out as shipyard, right? And the initial cost to open a shipyard was 100 grand. So immediately, no matter how many boats he sells, he's going to subtract $100,000 from his total price. To make each boat, there's a cost associated with man hours, labor, or the same thing, and materials, right? And so he multiplies, right? He subtracts a certain percentage of each boat for that for that material cost. And then, of course, X cubed, this would be your pure profit function. All right. Go ahead and give yourselves a score on that. Remember, evaluation, a lot of times it's far more complicated than this, and they give you a bunch of introductory junk about, specifics that you don't need. You got a question, Ed?
There, on the B part, I put it as 1 cubed minus 0.02.
Yeah, and that's totally fine, right? If you write that there, it's just, those are just things that don't really matter, right? Because 1 cubed is just 1, and 0.02 times 1 is still just 0.02. Yeah, and so that's totally correct. It's just a different way to write it. All right, number 10. Go ahead and give yourself a couple minutes, try and figure this guy out. All right, we're gonna move on a little bit fast just because I got a lot of stuff to get through by the end here. Oh yeah, I think I told you guys the final was gonna be 11 problems. It's gonna be more like 16 to 18. That's because I talked to Kate this morning about 11 problems. She's like, what, for a final? So you guys can thank Kate for that. She's like, no way, you can't do that. And I was like, why not? She just said, well, it's a final. She's like, you have 2 hours. I was like, yeah, I guess you're right. I'll make a few more problems. I'll make them all distance. Just kidding. All right. Okay, so for these guys, remember there's 2 solution types. There's one where you take a single LCD and multiply top and bottom by it, and there's another where you just you kind of like calculate the numerator and the denominator separately and then simplify afterwards. I don't know. I have a preference of the major denominator method or whatever, the main denominator method. So I'll do that one first. So I just noticed that I have only 2 denominators to deal with, y and x. If for some reason there was a t in there in the denominator, t would be part of my LCD, but since it's just y and x in the denominators, I'm going to multiply top and bottom by xy. Okay, I go ahead and distribute across the top. Xy times 1 is just xy. Xy times x over y is x squared. Right? Yeah. Okay, now I'm going to distribute across the bottom. Xy times 1, that's still just xy. And then xy times y over x, that's going to give me y squared. Okay, so now that I have that done, I'm going to see if I can factor anything out on both sides and cancel. This is weird. Okay, so I think I can factor out x's on the top, and that would give me y plus x, right? Factor an x out from here and 1 from here. Put it out front here. Whoops. Try and keep with red. All right, and then on the bottom, I have a y in both terms. I have 2 here and 1 here, so I'm going to pull them out. Now I have y times x plus y. Take note, this is the same as this, so those will cancel. And I'm just going to have x over y remaining. Yeah. All right, so the second method, if you want to use that, we just combine the numerator and the denominator first and then simplify. So I have 1 plus x over y, 1 plus y over x. So in the numerator, I want to add 1 and x over y, so I turn 1 into y over y, add that to x over y. And then in the denominator, I turn 1 into x over x and add that to y over x. So now I have y plus x over y in the top, and I have x plus y over x in the bottom. So now I use my rule for division, which means if you're dividing 2 fractions, you flip the bottom one and multiply. So I have y plus x over y. Oops, this should be a y. And then that is now multiplied by x over y plus x. Ah, don't do this to me. Oh. Sweet. That is awesome. Okay. There we go. All right, sorry about that. So, it backed me up a couple steps here. So I was writing x on the top and y plus x on the bottom. And as we can see here, right, this becomes all one fraction. and the x plus y's will cancel, and we'll get x over y, the same as we got up there. So it's just two different methods. They both land at the same solution. All right, problem. What's up?
On the first method for the LCD, x, y times the denominator, how did that work to like get to x squared, y squared? Like physically. Like if you worked out the problem, how would that work?
To get to x squared and y squared, how do you mean?
Like when you multiply x, y by the denominator, how is that supposed to work? I don't understand why it's...
Oh, like why it turned out to be this?
Yeah.
Oh, okay. So I have x, y. Good. That's a good, because yeah, I do kind of rush through those sometimes. Okay. So when we multiply x, y in here, that's obvious, right? It just ends up as x, y. But then we multiply x, y into this other one, we get y times what we multiplied in, x, y, over x still, right? And then our x's will cancel. Does that make sense? Yeah, and then you get xy plus, these two y's are multiplied together, y squared. Yeah, no, that's a good question, yeah. Sorry for rushing through those. No, sorry, Ed. Yeah, and that's, you know, if you're not sure what to do there, do it like this, like write it out, you know, like yeah, it's best to write it out. You know, when you're not super comfortable with distribution, when you haven't done it a gazillion times like I have, write it out every time. It's safer that way. All right. So moving on to 11. Here's a good one. I know you guys love these. Go ahead and try and solve this guy for x. All right. You guys should have a good idea whether you got the concept down or not. So for these guys, first thing we're going to consider is whether or not we want to restrict any values. In order to do that, we got to find out which values would violate any rules in this denominator, which isn't factored, right? We know that these two denominators say that x can't equal plus or minus 5, because then we'd be breaking a bunch of rules. So I'm going to go ahead and list all the denominators on the side, and that's going to help us find the LCD later anyway. So I have x minus 5, x plus 5, and then I have x squared minus 25. What does this equal? This is a special product, right?
X minus 5, x plus 5.
Yeah, a squared plus b squared equals a minus b times a plus b. So x squared minus 25 is equal to x plus 5 times x minus 5. Okay, so since I see these factors are the same as the other ones, I don't have to restrict any more values. So I'm just going to write up here, x cannot equal plus or minus 5. All right, so now whenever I have one of these equations with a bunch of fractions in it, and I don't like those fractions, I create an LCD and I multiply every term by that LCD. So to create an LCD, remember we line up our denominators, we choose one, and we see if it contains the other denominators. If it doesn't, then we have to add more factors. So I'm going to choose this one. It contains an x plus 5. It contains an x minus 5. So this is the LCD. So I'm going to multiply both sides, all terms, by this. X plus 5, x minus 5. I'm actually going to do that down here and give myself a little more room to do all this. So I have all right. So right off the bat, I already know that x squared minus 25 is equal to these factors, so I can just cancel both of these over on the right side. Now I'm going to go ahead and handle the left side. So I'm going to distribute this into the first term. So I have 3 times x minus 5, x plus 5, and that's still over x minus 5. All right, then I'm going to distribute this into the second term. So I have plus x minus 5 over x plus 5 all over x plus 5. And this equals plain old 2 because I canceled everything on that side. So now that I've distributed this LCD in, I go through and I cancel what I should cancel. So I have an x minus 5 on the top, x minus 5 on the bottom, x plus 5 on the top, x plus 5 on the bottom. Now that I've canceled everything, I just write what's left. So I have 3 times what's left, x plus 5 in parentheses, plus x minus 5. I don't really need parentheses there because it's not multiplied by anything. And that still equals plain old 2. Now I'm going to distribute this 3, and I'm going to have 3x plus 15 plus x minus 5 equals 2. So when I combine my like terms, now I have 4x plus 10 equals 2. If I subtract 10 from both sides, I can isolate my x. So now I have 4x equals negative 8. If I divide both sides by 4, then I can see that x must equal negative 2, because negative 8 over 4 is negative 2. So now I say this might be a solution. Let me circle it and put a little question mark here and go up and see if this was a restricted value. X cannot equal plus or minus 5. That's not 2. So yeah, this is a solution. If you want to check your answer on a problem like this, you just enter negative 2 for each instance of x in the original formula and make sure it turns out true. Okay. Do you guys see what's right here? Do you guys see what it says there? It's trying to read what I wrote. It's trying to interpret. Oh, it's changed it now. Did you see it? Yeah, it says A-70s, IA okay fatty. That's its interpretation of maybe like this or something. I don't know. That's funny. All right. Sorry, I'm easily entertained. Okay, so now we have a work problem. Number 12. go ahead and take a couple minutes and see if you remember how to set up a work problem. All right, you should have been able to set that one up by now. The setup for that one, and this is something you might want to put on your note card if you tend to forget it, is the work principle. And the work principle basically says if you have two people, person A and person B, doing the same job, you can solve their time for doing that job with this, T over A plus T over B equals 1. And there's two other versions of this, so if you prefer a different one, use that. To me, this is the easiest one to memorize. So, okay, so person A will be Bill. He can mow a lawn in 6 hours. Person B will be Kim. She can mow a lawn in 10 hours. So let's calculate how long together. So we have T over A, which was Bill's time, 6 hours. We have T over B, which is Kim's time, 10 hours, and that equals 1. So just like in the last equation, we had fractions involved. We didn't want them involved anymore. We're going to find a common denominator and multiply through by that. So my two denominators are 6 and 10. When I break those down, 6 is equal to 2 times 3, and 10 is equal to 2 times 5. I'm going to select one of those. I'm going to select 10, write it over here, 2 times 5, and I'm going to see if it's missing any factors from 6. It has the 2, it's missing the 3, so I add the 3 in there. This is equal to 30. Okay, so now I'm going to take that 30, I'm going to multiply both sides of my equation by that. So T over 6 plus T over 10 equals 1. So now I multiply both sides of this by 30. Okay, distribute into the first one, and I get T times 30 over 6, plus distribute into the second one, and I get T times 30 over 10, and that's equal to 1 times 30, which is 30. Now my next step, I go through and I simplify all these numbers here. So 30 over 6, what's that equal to? 5. So that's 5t. 30 over 10, what's that equal to? 3t. And 30 is still just 30. Now I combine these and I get 8t equals 30. So I'm going to divide both sides by 8. And I get t equals 30 over 8, which is 15 over 4. And so this is, what is this? This is 12 and 3/4 hours? Yeah. Sorry, not 12, 3. Yeah, 3.75 hours. The fraction would have been totally fine. I just like to calculate it out to 3.75 to make sure that my answer makes sense with the original problem. So the original problem says one guy is doing it in 6 hours, the other person is doing it in 10 hours. When they work together, obviously it's going to be a lower number. Yes, that makes sense with the original question, so I'm going to call that good. All right. Oh, come on. All right, so let's move on. Similar triangles. So suppose these triangles are similar. Oh, and I think, yeah, I changed your, do these numbers match your assignment? Yeah. Oh, are they? Oh, okay. We'll just swap those then. Yeah, sorry, I changed this at the last minute. All right, so go ahead and take a couple minutes and see if you remember how to work on similar triangles. All right, so this one's a pretty straightforward example if you know how to do it. These are just based on proportion, and so basically proportional says if these are similar triangles, then you know a leg over a hypotenuse is proportional to the same leg over the same hypotenuse on the other triangle. So we can set it up like this. We have 4 and 5 that are related to x and 35. We can use that to solve for x. So 4 over 5 is equal to x over 35. Notice that the hypotenuse, both the hypotenuses go in the denominator, right? You got to keep it straight like that. And both the legs go in the numerator. If you mix and match those, everything gets screwed up. Okay, so for this one, to solve for x, all we need to do is multiply both sides by 35. That's going to cancel the 35 in the denominator over here. And we're going to have 35 times 4. 35 times 4 over 5. So that is it?
7 times 4.
Oh, nice. That's weird. I calculated something wrong there. All right. So 28 is what we get for x. We go about solving y in the exact same manner, right? So now, instead of the first two numbers we pointed out, we're going to be using this, and it's going to be in the numerator with y, and we're going to use the same hypotenuses in the denominators. Okay, so we're going to have 3 over 5, that's equal to y over 35. Once again, multiply both sides by 35, which cancels the denominator, and we have y equals 35 over 5 times 3. And that is 7 times 3, which is 21. Alrighty, so that's a similar triangles example. Problem 14. Find the solution of this system by graphing. All right, just so I can finish before class is over, I'm going to start this one. So remember, if you guys are uncomfortable with your graphing, figure that out, because that's gonna cost you on the final if you're not sure how to graph. So for this first equation, these are both in y equals mx plus b form, and so I have a y-intercept of 0b for both of these, and I have a slope of m. All right, so this first one, y equals x minus 3, I have a y int equal to 0, negative 3. So I'm going to plot that point, 0 on the x-axis, negative 3 on the y, that's down here. My slope, m, is equal to the coefficient of x, which in this case is 1. Don't be fooled, right? It's not a 0 out there, it's a little 1. So if the slope is 1, I go 1 rise and 1 run to find my next point, and then I can connect those to something like that. All right, now for the second equation, y equals negative 2 minus 1. I'm going to once again just write what I have here. So y equals negative 2 minus 2x minus 1. My y int, that is equal to 0, negative 1. So that's where I plot my first point at 0, negative 1 right here. And then I have a slope m that is equal to the coefficient of x, which is negative 2 in this case. So now that I have a negative 2 slope, I can move 2 up and then 1 in the negative direction. Or I can move 2 down and 1 in the positive direction. Now I can draw my line in. And then I want to identify this point where they cross and estimate it. So I don't know. On the x-axis, this looks like maybe 0.75. That's probably not it. On the y-axis, I don't know, maybe negative 2.25. Close enough, right? Okay, so I still have 4 more problems to go. You guys take off if you want to. You can stay and do the rest of the problems if you want to. If you take off now, make sure you watch the video and complete the exercise, right? I'm not going to get all butthurt if you leave, though. Don't worry, I'm not going to hold it against you. I just want to finish this out, so I'm done. All right, so if you're sticking around, go ahead and start this one. And since we didn't have time to review the final today, I'm going to review that and release it on the website. So we have all tomorrow to review if we want to. If anybody else leaves, make sure you grab one. All right, so you should be able to set that guy up by now. One thing we'll notice right off the bat with this problem is that it's going to be a classic mixture problem. The reason why I can tell right off the bat is because they give us 3 different multipliers. So we're going to multiply each and every value just like you do on a classic mixture problem. So I'm going to create my table like I always do. Down the sides, we're talking about peanuts here, so we say peanuts and Brazil nuts. Total weight. Multipliers, and then dollar value or total cost or whatever. Okay, across the top I just do my 3 things that I'm mixing together and dealing with. So let's see now. So we have peanuts first, right? Peanuts. 2.52, not 25. Let me erase that. $2.52 per pound. And then we have Brazil nuts, which are $3.80 per pound because they're fancier. And then we want to, let's see now, it says they want 480 kilos of a mixture worth $3.44 per kilo. So I have the mix at $3.44. All right, so I'm going to just say the total weight of the peanuts in kilos is going to be X. Total weight of the Brazil nuts will be Y. And they told me how many kilos they wanted me to make, 480. So that goes up here in the total weight column. And that's a weird 8. Okay, so my multipliers, that's just price per pound, blah, blah, you know, percentage per gallon or whatever. In this case, it's price per pound, so I have 2.52. And for this one, 3.80 for 380 per pound. And for the mix, 3.44. Now, since this is a classic mixture problem, I just create my 3rd row from the first 2 rows. So 2.52 multiplied by X, that's the total value of the peanuts. 3.80 times Y, that's the total value of the Brazil nuts. And then 3.44 times 480. That is the total price of the mixed. Okay, we take our equation straight across the top and straight across the bottom. X plus Y equals 480, and then 2.52x plus 3.80y equals 3.44 times 480. That gives me 1651.2. All right. There's a lot of decimals here. I don't like those, so of course, elimination. What do you guys think about that, right? It's pretty cake to do elimination when there's all these weird decimals. So, okay, so I'm going to choose the x's, and that's going to make it easier, or I'm going to find the additive opposite of this x by multiplying this top equation by a single number. So what is that number? Yeah. 2.52. Right. If I say, look, I want to get the additive opposite of x, then I need the opposite of the coefficient. So I multiply the top equation by that. Negative 2.52. Negative 2.52. And then I'm going to write the results down here. So I have negative 2.52x minus 2.52y. And that's equal to 480 times 2.52. Negative 2.52. Negative 1209.6. All right, now I'm going to do my vertical addition. 2.52x minus 2.52x, that just goes away. When I subtract 2.52 from 3.8, I get 1.28y. And then when I subtract 1209.6 from 1651.2, I get 441.6. Pretty ugly numbers. Now, the y is attached to the 1.28 through multiplication, so I divide both sides by that to get rid of it. When I work this guy out on the calculator, I actually get something fairly nice. Y is equal to 345. All right, so now I got to go up and see what x is equal to. I've only done half the problem here. So I have x plus y equals 480. If my y is equal to 345, I just plug that in for y down here. So x remains. Y now turns into 345. That equals 480. I'm going to subtract 345 from both sides. And I get x equals 135. So those are my two solutions for this problem. If I want, I can plug them back into the original equations to make sure that they are in fact solutions. Okay, moving on. Only got a couple more to go after this one. Unfortunately, they're both word problems. All right, so go ahead and remember, it's cool. If you guys want to leave, you can leave. It's fine. What was that? Oh yeah, that's right. I added more in the end. I figured you guys could just write them on the back because there were two problems that I wanted you guys to go over in the review because they might be on the final. I had to add them at the last minute. Sorry. Yeah, it's Craig's car, and then there's one other one. All right, for these ones, maybe I'll just start going through them so you guys don't have to stay here for so long. All right, just you know, try to notice before the problem if you were prepared for that or not. All right, so yeah, that way we'll get you guys out of here in time. So for this one, I like to split these up into separate radicals. So I have root 165, root x squared, root y to the 4th, and root z to the 8th. So all of these, if you guys will notice real quick, the exponents are even numbers. To simplify an even numbered exponent under a square root, we just cut that number in half. I'm going to do it one step at a time though so that we don't get lost. So we could just cut those in half, but if we wanted to write them the proper way, we would leave x squared the way it was. And I say proper, I just mean like, you know, rigorous, but you guys don't actually have to do this on the test. Since I told you you that exponent in half, and that's sort of a rule, like you don't need to show me the intermediate steps. If you want to, though, that's cool. So for this one, I have y squared squared. I'm writing these in terms of squares, and for this one, I have z to the 4th squared. And so now I pull out whatever I was squaring. All right, and so the x squared, that gets pulled out, and that's just an x. The y squared squared, that gets pulled out, and it's a y squared. The z to the 4th, that also gets pulled out because that is what is squared. All right, notice I pulled out just this stuff inside the parentheses. Okay, so now I simplified all those variables. The last thing, I could have done this first if I wanted to. I'm just going to check out 165 and see if I can do anything with that. So I'm going to create my factor tree and see if when I get to the bottom I have any pairs. So 65 is 5 times 33. 5 is prime, so it just drops right down. 33 is equal to 11 times 3. These are all prime. There are no pairs here. There's nothing to simplify with that number, so it just stays there. If you have pairs, you can pull a pair out, but that's, you know, if it's just 165 and there's no perfect square numbers as factors, you can't do anything. So this is just x, y squared, z to the 4th, 165. All right, so that's it for that one. So this is one that's not on your guys' sheet, but it's a distance problem, so I thought we should go over one of those.
We have this one. It's a very bad.
Oh, you guys do have this one.
We're assuming we don't have it.
It's the 18 one that you don't have. Okay, cool.
10.
No, that one was just a copy from when it crashed earlier. Stupid software. All right, so so this is a distance problem. It's a pretty classic distance problem, so we're going to create our table. The rows are named after the people who are driving or the vehicles or whatever. So we have Craig and we have Marilyn. Now across the top we put what we always put, D, S, and T. Because of the classic equation D equals ST. All right, so when we read the problem, the first thing it says that Craig is driving 8 miles per hour faster than Marilyn. Let's name Marilyn's speed x, and let's name Craig's speed x plus 8. Okay, the second sentence says, in the same time that it takes Marilyn to drive 84 miles, Craig drives 96 miles. So there are two things that are very important to take out of these sentences. So first it says that Marilyn drives 84 miles, so her distance is 84. Craig drives 96 miles, so his distance is 96. But what's really, really important in this sentence is what it says right here, in the same time. So we're going to put a capital T there to tell ourselves this is the same time. Okay, so now we're going to set these guys up, right? So we know using the classic D equals ST equation that if we solve for T, we get D over S. So this T right here, this big T, this is equal to our D over S, right? 96 over X plus 8. And this big T is equal to the same one, or the same formula, 84 over X. So let's write that all out. So we have 96 over X plus 8 equals big T. Big T also equals 84 over X. Now on the next line, since they both equal big T, right? I mean, that can just go away and we can have them equaling each other. So now we have 96 over X plus 8 equals 84 over plain old X. Now we're going to multiply both sides by an LCD. Since both these denominators are prime, we just multiplied the denominators together to get the LCD. So I have X times X plus 8. Okay, so now over here on my left side, you'll notice that the X plus 8s will cancel. And on the left side, or sorry, on the right side, you'll notice that the X's will cancel. So the next line is 96X on the left and 84 times X plus 8 on the right. Now I'm just going to distribute over on the right side, which gives me 84X plus 672. All right, now I want to isolate my x's, so I'm going to subtract 84x from both sides. And I get 12x equals 672. If I divide both sides by 12, I get 56. All right, so Marilyn was driving, oops, spelled that wrong, 56 miles per hour. And then in the next line, which I'll skip because we're hurrying, in the next line you'll say Craig drives that plus 8. So Craig's driving at 64 miles per hour. All right, last one. Real quick, a discount price one. So, suppose we had this dude named Danny. He bought an ugly Christmas sweater at a 20% discount from the sticker price. The price of the discount, or the discounted price, was $85. What was the original sticker price for the sweater? All right, 3 important numbers. We have the original, the change, and the new. Our original, we don't know what that was, so we're going to call it X. Our change was a 20% discount, so we're going to write this as negative 20%. And our new, that was $85. All right, so now we just set up our equation, right? The traditional discounted price equation says the original price plus or minus the change. In this case, it's minus. The change is negative 20% off the original price, so 0.2x. That is equal to the new, which is $85. Now we just consolidate our x's, right? X minus 0.2x, that equals 0.8x. That is equal to 85. And so now I divide both sides by 8. And I work it out on the calculator, figure out what it was. 106.25. So that was the original cost of the ugly sweater, but they discounted it by 20%. So that's it. Thanks for sticking around a little bit of extra time.